push the project to the last day again?
I wasn't procrastinating. I was waiting for inspiration.
That's exactly what you said last time.
A regular PC can generate full multi-speaker conversations, with emotion, tone, and natural pauses, all included. And it doesn't require a high-end GPU. So how does this actually work? In this video, I'll walk you through everything from scratch. This might be one of the most powerful open-source voice models right now, FishAudioS2. And I'll also show you some practical use cases you can apply right away. Hello, welcome to Smart Vision. On this channel, I keep sharing the latest AI tutorials and practical tools. All workflows, materials, and resources from this video are on my Patreon and are available to download after you register. For supporters, I provide extra professional tools and deeper guides. If you like this content, consider subscribing and supporting the channel. Now let's get started. Before we dive into using it, let's quickly understand what FishAudioS2 actually does. At its core, it's a next-generation text-to-speech model. But the biggest difference from traditional TTS is this: it doesn't just generate sound, it also understands how you speak. For example, you can directly write things like, "A bit quieter, say it with a smile," or with some hesitation in your text. The model will follow these cues and generate not just the words, but the emotion and tone as well. On top of that, it natively supports multi-speaker dialogue. Within a single block of text, you can assign different voices to different characters, and the model will generate the full conversation in one go. No need to manually stitch audio clips together. Technically, it uses a structure called dual autoregressive architecture. In simple terms, one part handles what to say, and the other handles how to say it. This allows it to maintain natural-sounding speech, while also improving generation speed. Combined with reinforcement learning optimization, its emotional expression and vocal realism are already approaching the level of real human conversation. We need to install comfyui. If you have an NVIDIA GPU, search for comfyui on Google, open the site, and download the appropriate version. If you have an AMD GPU, download the AMD portable version of comfyui from the comfyui GitHub page. After downloading, extract it, and it will be ready to use. I'm only giving a brief demonstration here because I don't have an AMD GPU and haven't tested it myself. Also note that some comfyui custom nodes may not support AMD GPUs, so keep that in mind. Next, download the model. Although the node supports automatic download, the default model is very large, and not suitable for low VRAM setups. So instead, we'll use the quantized version, FP8. It only requires around 12 GB of VRAM, which is much more practical. Download all the required files, and place them into comfyui, models, FishAudioS2, Pro FP8. Finally, load the workflow. I'll share both the workflow and model download links on my Patreon, so make sure to grab them there. If there are missing nodes, click on Missing to download them. But there's one important caveat here. You might see a node listed as missing. Do not install that one, or your workflow will break later. This workflow includes 3 main features: standard TTS, single speaker voice cloning, and multi-speaker voice cloning. There's also an optional node for transcribing the original audio to improve cloning accuracy. If you're just testing, you can skip it by selecting it and pressing Ctrl+B. Select the reference audio you want to clone here. Make sure the length is between 10 to 30 seconds. Then choose the model. Since we downloaded the S2 Pro FP8 earlier, select that one. Next, enter the text you want to generate. There are a few key settings here that have a big impact on generation speed, so make sure to set them properly, otherwise it can be very slow. First, max new tokens. Do not set this to 0. Because 0 means no limit, which will consume a lot of resources and slow everything down. We can set the token count based on the length of our text. For example, if I have 100 English words, I can set this to around 140, and so on. Then set chunk length to 100. Finally, make sure to enable Keep Model Loaded, so you don't have to reload the model every time. Multi-speaker voice is the strongest feature of this model. It supports up to 10 characters speaking in a single conversation. There's one important thing to note. You must include speaker IDs in the prompt. The format should be speaker_number. Make sure not to get it wrong. Otherwise, it won't be recognized. Here, you can choose how many speakers you want. After selecting the number, the corresponding speaker slots will appear. Upload a reference audio for each speaker. Other than that, you can leave everything at the default settings. After going through all those settings and parameters, let's take a look at the actual results. I've prepared 3 tests here, starting from simple to more complex, so we can see how it performs step by step. First, let's look at the most basic and also the most important part, emotion control. I'm using the same sentence, but asking the model to express it with different tones. The first one is the default tone, basically just reading it normally. The second one has a slight sense of laughter. And the third one includes a bit of hesitation and pauses. You can pay attention to a few details, like where the pauses happen, the changes in speaking speed, and the emotional variation. All of these details affect how human it sounds.
Hello, this is Smart Vision. Hello. This is Smart Vision.
Hello, this is Smart Vision.
This is something many traditional TTS systems struggle with. They can read the words correctly, but it's hard for them to convey feeling. But this model is already starting to express emotion. Next, let's look at single speaker voice cloning. Here I'm using a reference audio of about 20 seconds and generating a completely new piece of speech. First, listen to the original audio.
Hey guys, happy Sunday. I just wanted to hop on here and share a quick update about my week. I've been exploring some new coffee shops lately, and I think I found a new favorite spot downtown. If you have any recommendations for a good oat milk latte, let me know in the comments.
Then listen to the generated result.
Take a deep breath and let it out slowly. Sometimes, in the middle of a busy day, we forget to just be. Remember that it's okay to slow down. You don't have to have everything figured out right this second. Just focus on the present moment and keep moving forward.
You can compare a few things, like whether the tone is similar, whether the speaking rhythm is preserved, and whether there's any noticeable AI feel. In most cases, as long as the reference audio is good, the generated result is usable right away. For example, for video narration or character voiceovers, you usually don't need any additional processing. Finally, let's look at the strongest feature of this model: multi-speaker dialogue. Here I've set up 2 characters, each with a different voice. Then I wrote a simple conversation and let the model generate it in one go. You can focus on a few things: whether the voices are clearly distinguishable, whether the dialogue flows naturally, and whether there's any confusion between speakers. In many traditional workflows, you would need to generate each line separately and then stitch them together manually. But here, the entire conversation is generated at once, with speakers assigned automatically. This makes a huge difference for story-based content. At this point, you can probably see that it's not just generating speech. It can control emotion, clone voices, and even generate full conversations. This is no longer just a simple TTS tool, it's more like a complete voice generation system.
Hey guys, happy Sunday. I just wanted to hop on here and share a quick update about my week.
I've been testing this new setup for a few days now, and honestly the performance is a game changer. The rendering speed is much.
You pushed the project to the last day again?
I wasn't procrastinating. I was waiting for inspiration.
That's exactly what you said last time.
Well, it got done in the end, didn't it?
Now let's look at something more interesting. We can combine FishAudioS2 with LTX 2.3. So instead of just generating audio, we can generate a complete dialogue video. The idea is simple, just 3 steps. Bind voices to characters. In FishAudioS2, upload a reference audio for each character. This defines the voice identity. Step 2. Generate dialogue. Assign lines to each character. For example, A uses one voice, B uses another. The model will generate the entire conversation in one go. Step 3. Send audio into LTX 2.3. Use the generated audio to drive visuals, timing, and even scene transitions.
you push the project to the last day again?
I wasn't procrastinating. I was waiting for inspiration.
That's exactly what you said last time.
At this point, you're no longer just generating voice. You're creating a full video with characters, voices, and natural pacing. One more tip. Before running LTX 2.3, make sure to disable Keep Model Loaded, so the model releases VRAM and LTX can run properly. That's the full workflow. From voice generation, to multi-speaker dialogue, to final video output. It forms a complete content creation pipeline. If you're creating content, this setup can save you a lot of time. If you found this helpful, consider liking and subscribing. All resources are available on my Patreon. See you in the next video.